Greetings for the day. I am Maanya of class 8D and I will be presenting a project on my favorite mathematical topic, the Fibonacci sequence and the golden ratio. I have made this project using Adobe Spark and GeoGebra. I will be talking about its origin, the concept behind it, its examples in day-to-day life, how we can prove it, how can we make it using GeoGebra, and its appearance in famous artworks. The origin of the golden ratio. A 13th century Italian mathematician, Leonardo Pisano, also known as Fibonacci, in a sense, son of Bonacci, had pondered the question: how many pairs of rabbits can be produced from a pair of rabbits in 1 year if there were optimal conditions? Well, female rabbits always give birth to pairs, with each pair consisting of a male and a female, while they can't reproduce until they are at least 1 month old. So, for the first month, there is only one pair. In the second month, when the female gives birth, we have 2 pairs of rabbits in all. And similarly, during the third month, the original pair of rabbits reproduces another pair of newborns while their first offspring grows into adulthood. This gives us 3 pairs of rabbits, in which 2 will give birth to 2 more pairs in the 4th month. Fibonacci eventually concluded that in a year, 233 pairs of rabbits would be born. The order goes as 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, and on to infinity. Each number is the sum of the previous 2 in the series, like 1 plus 2 gives us 3 and 2 plus 3 gives us 5. This series is known as the Fibonacci numbers or the Fibonacci sequence, and the ratio between any 2 consecutive numbers is 1:1.618034 and is called the golden ratio, while 1.618034, which is irrational, is known as the golden number. The concept behind the golden ratio. The golden ratio can be used to describe the proportions of everything from nature's smallest building blocks such as atoms to the most advanced patterns in the universe like celestial bodies. Nature relies on this proportion to maintain balance, and so do financial markets. The Fibonacci sequence goes on to infinity, and it provides us with the means to understand the golden ratio, which is represented as phi. That is a Greek letter, or 1.618034, that is an irrational number. When any Fibonacci number is divided by its previous number, the resulting number is approximately equal to phi. And the further we go in the series, the more closer the values get. Phi is calculated using 1 plus root of 5 divided by 2. As we can see, the rule continues up to infinity with 0 plus 1, which is equal to 1, 1 plus 1, 2, 1 plus 2, 3, and so on. The Fibonacci spiral in everyday life. The Fibonacci spiral can be witnessed in day-to-day life as well, like in storms and hurricanes. On the human face, from our ears to the nose to our mouth. As a matter of fact, we can see many Fibonacci relationships on our whole body. Shells are the most beautiful representation of the Fibonacci spiral. Proving the golden ratio. For any beehive, if we divide the number of female bees by the male bees, we will get 1.618, which is the golden number. Sunflowers have opposing spirals of seeds that have 1.618 ratio between the diameters of each rotation, giving us the golden number. The human body, if we measure from our shoulder to our fingertips and then divide this number by the length from our elbow to our fingertips, we'll get 1.618. So, don't all these things prove the golden ratio? Now let's make the Fibonacci spiral using GeoGebra. As we know that the Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13 on to infinity. We'll be making squares of these dimensions in descending order, starting with the square of side 13 square units, then 8 square units, 5 square units, 3 square units, 2 square units and 2 squares of 1 square unit. We will now take a circumpolar arc and place it on points B and D by taking point C as our center. Then an arc from point D to point K, taking point E as our center. And we'll be continuing this till we make arcs in all the 7 squares. The spiral that will be formed will be known as the Fibonacci spiral. The spiral that we now see inside the 7 squares is the Fibonacci spiral. We will now be measuring their dimensions to confirm their lengths, with the biggest one being 13 square units, the second one 8 square units, then 5 square units, 3 square units, 2 square units, and the smallest 2 being 1 square unit. This is how we can make the Fibonacci spiral easily using a simple app known as GeoGebra. The Fibonacci spiral can be seen in many famous artworks like Da Vinci's legendary Mona Lisa and Dali's Sacrament of the Last Supper. Isn't the golden ratio just unavoidable? Thank you. I hope you enjoyed my presentation.